the third episode of these workshops. Just to recap, there was the first workshop where Brian was describing the emerging technologies, the issues, the business problems, and how to address them now with the new technologies. Why? Can I keep continuing? Right. So when in the second one, I was describing, I was more introducing at a lower level what a data management platform is, and also giving you some hints and bits and pieces of what, how an architecture should look like. Now, in this third presentation, instead, it will be divided in two parts. The first part will introduce to you at very high level the different ways that we have for connect to other systems, and other systems can be databases, can be files, can be also Spark executors. Okay. Well, in the second part, that is, let's say, data management techniques and design, I decided to show to you an end-to-end scenario, because I'm actually showing you how a data management platform can be used for implementing an end-to-end scenario with all the different parts that we talked about in the previous sessions. I think would give you a better understanding on what could be a good data management technique and design. So just to recap about a few concepts that we described the last time, basically we gave a proper definition of what is data management. And basically data managements are all these disciplines that are needed for extracting information from data. Okay, and basically it can be divided in few phases. Okay, so the acquisition, the validation, the storing, the processing, the sharing, and the governing phase. Last time I described all of them. Well, now we'll be more concentrated on the acquiring, so on the acquisition. It's not proper. Actually, this morning I realized that probably there would be another slide that I should have added. I didn't have time, but I will talk about that later on. So basically, when we are talking about acquisition, we are talking about the data ingestion part. Okay, so that means acquiring data from different sources or writing data to different targets. And basically, there are the two dimensions, the nature of the data and the speed of production of the data, that determine which kind of sources and targets we are using during our let's say data pipeline implementation. And so basically also here I'm enlisting also we can have database and Datalake direct connectors, some structured data connectors, and so on and so forth. Let me go now a little bit more in deep on this part. So the first kind of connectors that are even the most common and the ones that you probably use in your daily life with the data management platforms are database and Datalake connectors. Basically, these kind of connectors can interact with these sources or targets using some drivers, okay, that can be GDBC, can be proprietary, can be open source. And basically, these screenshots are taken from Talend because it's the platform that I know the most, but you have similar concepts, if not even the same icons in every modern data management platform. And so basically you can have components, for example, for reading and writing to a database. For example, in general, the output components are the components for writing to a specific target, while the input components are the ones for reading from specific targets. And you can have many other things also for executing the store procedures, for implementing ELT logics. And this is for databases, but it's also applicable the same to cloud. So for here, for example, you can see that we have the possibility of interacting, of reading and writing to and from Azure ADLS Gen 2, as well as many other kinds of databases that can be also NoSQL databases like MongoDB and so on and so forth. So this is probably the most used category of connectors that a data management platform can have. Then the second one that is very important is for the non-structured data. As I was saying last time, we were defining the non-structured data as unprocessed data, and that can be files, can be videos, can be mails, and so on and so forth. So usually modern data management platforms come with a set of components that allow you to read and write to these sources. What I would add, so here you can see that there are different RF, also the file input row for reading files that can be any format. But what I would add when it comes to connectivity and non-structured data is that what is very important for a modern data management platform is providing you also with powerful tools for transformation. For example, this is a screenshot of what we call the Talend data mapper that is specifically used when you want to map very unstructured data, for example, to a structured format. So this is an example, for example, of mapping of EDI file to an XML hierarchy. So usually when it comes to connectivity with no structured data, what is important, especially when evaluating a data management platform, is checking which ones are the different connectivity components for the different kinds of sources, as well as understanding what is the level of power of transformation that the tool has. Because in most of the cases, when it comes to unstructured data, it's more a matter of having a powerful mapper rather than a single component that reads a specific format. Then the third kind of components that are used when it comes to connectivity are the API clients. You know that, I mean, I think that you already realized that we are more and more living in a world where the applications are exposing data through services. And these services can be API, REST services, web services, even sockets, okay, direct sockets. Anyway, there's the concept of application that exposes some information through services. So what is important for a data management platform is having components for interacting with such services. And you can see that, for example, here I'm showing you the TREST client, the TREST request and response, and the ESB consumers that are mostly used for interacting. So on one end, for consuming services, and here also for creating services around it. Now, and here it comes to the slide that I didn't have the time to add so far. What is important right now is that when you think about components for connecting to API services, we're not only talking about the services for retrieving or pushing data, okay, information in general. We are also talking about services, for example, in the case of Databricks, of services for triggering the execution, the execution of a Spark job. So actually, when it comes to connectivity, we are also talking about connectivity to different kinds of services that are not limited to services that are providing data. And the example is Databricks. Databricks, as I was anticipating last time, is like a Spark pay as you go structure. And you interact with it through APIs. So that means that you push your job using one API, and you trigger the execution, the Spark execution of the job through API. And actually, for doing this, you will use a T-REST client component. So a component that is able to consume the services that are exposed by a different system. Then another very important kind of connectors are what I call the message queues connectors. You know that nowadays we have let's say that now it's been more than 10 years now, that we have this word called the Internet of Things. Because basically we have more and more devices that are connected with each other and with internet that are producing more and more data. And not only so big volumes of data, but also data that comes with high velocity. If you remember, also last time I was mentioning the 4 Bs of big data. Actually, when it comes to these kind of scenarios, most of the times you cannot rely on normal databases, so the databases like Oracle, SQL Server, and so on and so forth, because most of the times you need so much velocity that this kind of systems that rely on a storage that is persistent on the disk cannot work. And this is why more and more technologies that are message queues that exist since ever. I was working with JMS probably more than 15 years ago. But actually, right now, they became central. And then, since they became central, a good data management platform, especially when it wants to deal with real-time or near real-time big data, or in general with data that has big velocity, they need to have connectors to such queues. And actually here, for example, there are some examples. There can be some connectors to Kafka, connectors here you can see to JMS, to Microsoft MQ, and so on and so forth, as well as other kinds of connectors. This is a screenshot taken by our ESB part. So you can see the AMQP protocol, also here JMS, Kafka, MQTT, that is basically the most used one for Internet of Things. So these are, so also these kind of connectors are quite important, especially when it comes to high velocity data. So let's say that given this, that was a very high level overview of connectors, because the first part of this workshop was dedicated to connectivity. Right now, instead, I want to pass to the second part of the workshop. And the second part wants to describe you how to approach a scenario, okay, let's say a business scenario, using a data management platform. So this is just this is just a screenshot of the architecture of Talend, where we have the different components that have different roles, and also the studio for implementing the jobs. You have one part for administering the entire platform. You have one server, the data preparation for creating preparation, stewardship. I was describing at very high level these different components, but actually I want to put them all together in order to show you how a data management platform can help solving a specific business use case. Of course, this is a Talend-centric. I work for Talend, but in general, what I'm showing you now, you can apply it probably with just some different forms, okay, and probably some pieces will be in different parts, but actually you can apply this kind of concept to all the data management platforms that you have. So for the use case that I'm going to describe, there is this company that we called it Acme. Honestly, I don't know why we are calling it Acme, but I saw that in all the demos that we are having, we keep calling it Acme, so I called it as well. And actually, we have customer information across 3 different systems: Salesforce, Twitter, and Marketo. And what we want to do is creating one single source of truth of customer. So that means having one table where we have unique instances of our customers. Okay, that is what, let's say, usually is being referred as a master data management scenario. Okay, we prefer now, also according to the latest recommendations of Gartner, we prefer to define it an MDM data hub. Now, in order to architect a data management solution, we need always to keep in mind that what we can define a data pipeline is always composed by four main steps that can happen in different orders, can happen also multiple times during our data pipeline, but it's important to define them very clearly. The first one is the collection phase. And in the collection phase, we collect, so we retrieve data from our different sources. Okay. In our case, we want to collect the data from different sources that are Salesforce, Twitter, and Market. This is a screenshot taken from the studio, the Talend Studio, that is our graphical development tool. And actually, you can see that we have the first phase. This is a job. Okay, so this is actually a job that is executed from the beginning to the end. So it's a batch job. And actually, the first part is actually retrieving data from from these three different sources. Okay, and actually, we have more, as I was anticipating, more than 1,000 between connectors and components that you can use. And these are part of them. I show them in the first part. The second part is the governance phase. Now, when we are talking about governance is quite a broad concept, okay? Because governance can mean understanding the quality of the data, but can mean also understanding where the data is coming from, where it goes, who is accessing it, and so on and so forth. So actually, in this demo, I divided the governance phase in three parts. Now, the first part is the profiling. And in our scenario, what we want to do is measuring the quality of the data that is coming from one specific source, Market. In order to do that, let's say that in the platform itself, in Talend, but also in other data management platforms, you often have different parts, different ways of profiling the data, also in different tools. So, for example, this is an example of the profiler that we have in our studio. So basically, here you can see that we have the columns of our data, and here you have some indicators. Okay, these are predefined indicators. You can also create your own, of course. But basically, what you do so far is checking and unchecking the correspondent. So, for example, here, state, I want to apply the standard indicators, row count, node count, distinct counts, and so on and so forth. But then I want also to apply a validation over a specific dictionary. Okay, so I want actually here in this US state code, I have a list of admitted values for the US state code. And actually what I want to do during this phase, so with this tool, is creating a data quality analysis. Okay, so something that also graphically shows me the quality of the data based on the indicators that I set so far. Actually, I can create also more analysis on different tables and merging them all together in one single report. I can also write this information into a data mart, into a data quality data mart, that I want to interrogate with my own business intelligence tool for creating, for example, real-time data quality dashboards. So what happens? So we retrieve the data, then we profile the data, and actually while we profile the data, we realize that there are some actions that we should perform in order to cleanse the data, so to improve its quality. In order to do that, In Talend, for example, we have what we call the data preparation portal. It is a portal where users can access and can create using this interface that, if you can see, is really similar to Excel. So without writing even one line of code, they can write what we call preparation rules. So actually, based on the results of the profiling, we might want, for example, to format a specific phone number. You see here, for example, here we have the name of the columns. While here we have, let's say, the semantic type that has been automatically inferred by the system when this preparation was created. So that means that, to make it simple, this column has been marked as being an US phone. Since it's been marked as being an US phone, here we have a little profiling. So we can see that we have part of the records that are not correct, part of the records that are empty, and a big part of the records that are correct. Okay, an example of a record that is not correct is this one. You can see that it's marked with this orange straight line. And actually, oh, sorry, let me go back. And so actually what we are doing so far, selecting here the functions, selecting here the column, we are creating all these rules. And these rules, we are creating them, I repeat, for improving the data quality that was measured during the profiling phase. So another very important phase, so in the third phase of our data pipeline, is the transformation phase, because actually we need to transform the data for different goals. So first, we want to apply the data preparation rules that we created. So let's say that in the previous phase, we simply, based on the profiling part, we created some specific data preparation rules, but then we want to execute them. Another reason for the transformation is that we want to map the data to the final format, what we define the common data model. So the schema that will be so the schema of our golden table. So the table that contains the unique instances, the unique customers. And also what we want to do, we want to try to apply some automatic rules for the duplication. And usually, for who is more familiar with the duplication word, actually we are talking about the exact and probabilistic matching. And so in order to do that, we have in our job different parts. So we have this component, for example, that executes the data preparations that we created in the portal. So actually, what happens is in this component is that you configure it. So you simply you configure it in order to have it pointing to the data preparation portal, to a specific preparation, and then it will simply, once you run the job, all the data that will transition over this component will have all the rules that we defined applied. Then there is the transformation phase, so the mapping to the common data model, because actually the data that is coming from these three different sources is data that has different formats. So, for example, Marketo and Salesforce will have a lot of columns, while Twitter will have only 4 or 5. But on the other hand, Twitter will be the only one that will have the Twitter account field. So actually here is where we are mapping everything onto our common data. Well, here we are using this component that where we define some, as I said, exact and probabilistic rules for the duplicating the records. So just to understand, to let you understand better what I mean so far, here we can write, for example, that if the email, the first name and the last name are the same, then this component needs to group these entries together. Okay, or going more, and this is an exact type of matching, while a probabilistic type of matching can be if given two rows, okay, that are coming from different sources, if the two last names have a proximity of more than the 80%, and with proximity I mean the appliance of some algorithms for measuring them, then group them together. Okay. So once we create this, so we apply our data preparation rules, we map all the different formats to a common data model, and we apply the automatic deduplication, the automatic deduplication rules. What happens is that what we can do, and here we are going to the part 2 of the governance, we want actually to send the data that we weren't able to deduplicate in an automatic way, reaching a specific level of confidence, okay, that we measure, that we configure here. We want actually to have human people, so human beings, executing, performing the deduplication manual. People that we define stewards that are accountable for the actions that they are performing, okay? So here, before sending data to the stewards, we mask the personal data. I wanted to put this step because I think that, especially now, when we are talking about compliances, GDPR, POPI, or any kind of compliance that is there, let's say that all of them say that we cannot share personally identifiable information unless there are specific criteria that are matched. Now, here we are supposing that since we are sending data to the stewards are human people, and actually it might be that we don't want to give them access to all the personally identifiable information. Actually, we mask the data and then we send them to the stewards. Now, once the stewards, at this point, they log in into another portal that we are having, that is specifically where its goal is specifically giving the stewards an instrument to perform manual activities on the data. Manual activities, by the way, that are constantly audited. So everything that the steward is performing here will be audited. So here in this scenario, you can see already that I masked the two fields, okay, that are email and phone, and you can see it here that the email and also the phone numbers are masked. What the steward can do here is for each record, this is the golden record that has been proposed by this automatic deduplication component. And actually what the steward can do, simply pressing here, there is a little arrow here. Now this is a screenshot, so you cannot see that. But once you hover on the field, you have a little arrow here that pops up. So for example, in my case, So in my case, for example, the name that was proposed was Gulom, but Gulom, it's not the right name. So what I did so far was pressing here a button, and automatically this field is been, let's say, promoted to the golden record, as well as this Twitter account. It wasn't there by let's say, given as output of the duplication component. So what I did so far was pressing here and promoting this field. Once everything is consolidated, the steward can press this little lock and send his or her activity to validation. Now, when it comes to validation, especially when we are talking about this can be defined business users, okay? And so, especially when we are talking about business users, most of the times we need some kind of process to put in place, okay? And in traditional MDM solutions, so in traditional solutions that let's say were wanted to solve let's say most of the MDM scenarios, what was a big point was actually the usage of BPM, so business process management, in order to model this kind of approval processes. But actually, what happened is that unless there are very mature companies that were ready with a BPM system in place, in most of the scenarios, there is no need of validation, okay? But even if there is the need of validation, in most of the cases, the process that needs to be put in place is a linear process. So where you have stewards that are sending data to some validators are simply saying yes and no, okay? And for doing that, you don't need a BPM tool, okay? And actually here, in this, especially in this kind of portal, we are also doing the definition of what we call campaign, okay, that is so a specific instance of the activities that can be performed here. You can also define what is the approval process, okay. Now, once the stewards perform these actions, so once the stewards deduplicate manually what the machine wasn't able to deduplicate with a level of confidence that was enough for us, actually, let's say that this the end-to-end of creation of our single source of truth is completed. Okay, and just to recap the steps, we collected the data, we profiled it. Based on the profiling of the data, we created some what we call data preparation rules. Then we applied these data preparation rules, we mapped our data to our common data model, and we applied some automatic deduplication rules. And then for all those rules that we weren't able, let's say that for all those scenarios where the component wasn't able to deduplicate them with a level of confidence that was enough for us, we decided to send data to stewards, so to human people that are accountable on the for the actions that are applying on the data. They actually deduplicated them manually, and then so we brought back. Let's say here I'm missing this next step, but actually what we are doing is writing back in our single source of truth also this information. Now that we have our single source of truth, we need to understand what we are going to do with that. Okay, so we are simply leaving it where it is. Can be a database, can be a data lake, that is simply inspected by some business intelligence tools for doing reports. Or, for example, we need to have this single source of truth, so this golden table exposed and used for the operativity of your or my systems. In this case, if this is the case, we need to share the data somehow, okay? So we need somehow to make it available to the different consumers, and different consumers might be also a data mart. Creation of a data mart is a way of sharing the data, okay? Because actually what you are doing, you are taking the data that is in one format and you are transforming it into another format that is consumable by, for example, a business intelligence. But let's say that when we are, as I was anticipating before, we are living more and more in a services-oriented world. So when we are talking about sharing, we are talking also about the possibility of creating APIs around the data. And so actually, what you can do is creating some REST APIs. Here, this is, for example, this is an example of creation of, let's say, for an API that exposes 4 methods, okay? A get customer by ID, a get all customers, a create customer, and a delete customer. You can see that at least in Talend is done completely graphically. And actually, here, on one end, we have the creation of a server-side component or something that is in listening, okay, because we are exposing services, okay, and this is basically done by this component. But actually, for the rest, you can use in your when you define REST APIs, at least within Talend, you can actually reuse the same components that you are using also for your standard jobs. So here, for example, you can also decide to apply data preparation rules, or you can send data to stewards, or you can perform complex transformations, and so on and so forth. But what is important, the concept that is important, is always keeping in mind that once you have your data transformed, okay, and also with the quality that is enough for you, the second question that you need to pose to yourself, probably it will be the 1000th question, but let's say that the next question to be posed is, okay, what am I doing with this data? And how this data needs to be shared. Let's say that right now, so we have our master data. We created APIs around our data so that we have also any interaction with us, with the external systems, can be also mobile applications. But then it comes to the third and last part of the governance. And the third part, for understanding the third part of the governance, imagine that you are the CDO of the company, okay? And actually the CDO of the company has quite big responsibilities, especially nowadays. And imagine that you have a very complex environment, okay? And imagine that you work, for example, in telcos, okay? Telcos are one of the most complex environments where you can have hundreds of sources, very complex transformations, and more business intelligence tools that are producing different reports for different business structures. And actually, the CDO is one and needs to and has the responsibility of all of this. No? So first of all, he or she will need a holistic view of all the systems and components that are part of the data infrastructure. Understanding which ones are they, how they are interconnected with them, between them, and so on and so forth. Then another very important concept when it comes to let's call it high-level governance, is also understanding, what is called performing what is called the lineage. So understanding, for example, given a data in a specific part of your infrastructure, where the data is coming from. What are the transformations that produced that specific result? For example, always the CDO. The CDO is always checking. I'm saying the CDO, I mean any manager, okay, business manager, but I like to say the CDO. And so the CDO is taking a look to reports, okay, and every day realizes that there is a field that is an important field, for example, that contains, I don't know, an amount of money that he or she needs to authorize, no? That is always wrong in these reports. So how does it work without a system that helps you? It works that probably the CDO will pick up the phone, will call the guy that knows another guy that knows how the process was, but then the other guy quit the company, and so on and so forth. And this is the mess that I'm pretty sure that all of us already. So at least, if you're lucky, just once in your life. Unfortunately, I saw that many times. As well as the lineage that can be called back, let's call it backward lineage. Okay, so understanding where the data is coming from and what are all the transformations that happen. But you can have also the poor IT manager instead, that is pushed by the developers that are telling you, hey, we need absolutely to change the format of this field. And imagine the format of the field of the beginning of the chain of the systems that you can have in a very complex environment. And understanding the impact of any change can be really, really difficult. And so also here, traditionally, how it works, you pick up the phone, you call here, you call there. And it's also, first of all, it's a time-consuming activity, and is also very error-prone activity. Then a third big problem is, okay, let's say that we are a result of a merger and acquisition, okay, between different companies. And actually, we are talking about, so you have one company that is talking about, or even probably it's even simpler. Let's talk about the two different departments of the company. Okay, one that is, let's say, an operative department, and the other one is the finance department. When they are talking about address, for example, probably the operative part of the company, when it talks about address, means the address of the customer. Well, for example, when you talk with the finance part, probably they mean the address for sending the invoices. So actually, address means two different things to different departments, and this is quite a big problem when it comes to governance. And so actually, what the, let's say, I say it's CDO, what let's say the business user wants is also to create a common meaning for all the terminology that is used, because it saves time, and it also removes ambiguities. So it facilitates the communication, it improves efficiency, and at the end, it's something that can be measured in terms of economical savings. And then the last but not least need is performing searches. I mean, also here, now, when you have very complex systems, and imagine that you have, I don't know, 48 places where you have email, and I mean, you need to find only one specific one. Okay, this is something that you need. A platform, a tool that allows you to perform searches efficiently. There was like I think it was a statistics that was coming from Gartner. I never remember the numbers, but it was something like the 68% of the time is wasted in looking for information in the system. So given all these needs, what is needed at this point in order to facilitate the life of business users is what we call a metadata management platform. Okay, that is a part of our data management platform. So let's say that the data management platform, see that as the biggest, the bigger container. Okay, let's say that the metadata management part can be seen as, forgive me the repetition, part of the data management container. Okay, so in this case, the holistic view. This is, for example, the holistic view of the scenario that I was describing so far. So here we can see that we have different talent jobs. For example, we have initialized sources that populates in the beginning the different sources that we are using. We have the duplication job, that was the one that I was showing you so far. We have the resolution job, that is the one that I haven't shown you so far, where all the activities that have been performed by the stewards are propagated back to the master table. And then we have also the REST APIs here. That is the little job that I showed you, where in the sharing phase, so where we created APIs around the data, as well as the semantic mapping, because actually what we have a dictionary. Here, for example, a dictionary that is called finance. Finance will have different categories, and every category can contain or another category or one or more terms. Okay, so you see that you can create hierarchies at this point. And then here we have also the semantic mapping. That is the mapping between some terms that are in the dictionary with some of our metadata that we can have. And metadata can be, for example, a specific field of a specific table of a specific database. The second part, the data lineage. So here, for example, what we want to understand is where the email field that is part of our master table is coming from, and who is transforming it and how. Actually, also here, just selecting the field, pressing data flow, we have the complete data we have the complete data lineage. of this field. And clicking also on the different connections, we have also the name of the job that is performing this transformation, and we can drill down within this tool at the level of detail even of the single transformations that are happening in the job. So actually you can see that from one single point, actually you can control many aspects, and especially you can answer to all the questions where the data is coming from and who is transforming it and how as well. Here, this is just a little, let's say, a little bracket that I open, and actually within these tools, it's very important, and these are metadata management tools. Here I'm showing you one. As always, this is Talend, but you can apply it in most of the other vendors. Actually, what is needed right now, more and more we see also what is called the data monetization. Okay, so creating a value that is economical value starting from the data. The more now is needed to have a system that on one end allows business users to interact and to communicate within each other. And so actually you need something for example, recommending a data or raising alerts. Hey, watch out, this field is always wrong. Hey, watch out, there is never, the email is always in the wrong format, and so on and so forth. You can recommend also the single metadata as well. And you can also certify the single metadata. Single metadata, as I said, the metadata can be a column, can be a database, can be a table of a database, can be a file, can be anything that describes the data. Metadata is data that describes the data. Then, as I hear, this is, for example, a screenshot that shows you the definition of the glossary. So here, for example, we have a specific category of my finance glossary that is called GDPR, and within the GDPR are written all the terms that are mentioned in the document. You can see that, for example, here we have the definition of personal identifiable information. You can also have, like, let's say, its explanation in rich text format. You can, of course, have hierarchies here. So you can also mark that email, last name, first name, US address are all personal identifiable information. Okay. Then, once you take this information, so you have the terminologies, okay, and you make a connection between these terms and your metadata. So, for example, you connect this email address term with the email address field of the master data. So, creating actually what we call a semantic mapping. Then you can do what is called the semantic lineage. And the semantic lineage, I think, is one of the probably top and the highest level features that you can have in metadata management tools, because from here you can see that we have that the email address that is part of our GDPR category, that is part of our finance glossary, is connected to this specific field of this specific table. So actually what we are saying is that what is here in this field is described by this concept. And once you do something like that, you can answer to questions like the CDO always, that wants to know what is the impact of GDPR over the entire system. Actually, here, what the CDO can do is simply checking the personal identifiable information. Here, I didn't do that because it's a bit more messy, the diagram, so I chose just one single field, that is email. But here, it could be also personal identifiable information, and here, instead of one field, you would have seen more fields. And actually, the CDO or whoever can actually understand in one single screen and can also drill down at the maximum level of granularity, can see from one single screen what is the impact of GDPR over the entire system. So can answer to very complex kinds of questions that might appear. And last but not least, the searching part here. For example, you can have a full text search over the entire metadata management. The metadatas that are composing your infrastructure. So just to wrap up, that was the last slide. We have a scenario, and I wanted to show you how the different parts of a data management platform, here of course this is Talend centric, but believe me, every kind of data management platform in a way or in another follows the same principles, because you will always have a collection phase, you will always have, let's say, a profiling phase where you want to measure the quality of the data. You will have a transformation phase where you transform the data, applying the rules for cleansing it or mappings or whatever kind of transformations. Then you have the sharing phase. Okay, so you have again the governance phase, stewards, and so on and so forth. You have the sharing phase where you are transforming the data in different to be properly consumed by the different consumers that you might have. And then at the end, the big hat that you put on top of all of this is the metadata management part that allows higher level users, and not only, to have a central point of control of what's going on. And that completes, let's say, what we define a modern data management solution. Okay, so I finished so far. I don't know if there are any questions. Let me check, because last time I figured out that I wasn't checking properly here. All right, so we have, so thank you everybody. It was a pleasure. Please feel free to reach myself, Brian, Redington guys for any question that you might have. I mean, we'll be more than happy to answer. And I think that there will be the last episode of these workshops. It should be when, Brian, next Monday, I don't remember. I don't know. Okay, all right. Anyway, you have the calendar. You can double check that. All right, guys. So thank you very much, and see you on the next workshop.